Welcome to another episode of Statomatic Science. We're going to be taking a look at the turntable again today, and I'm hoping this is the last episode before we start actually digging into things and really getting into the nitty-gritty of how this is going to work. But before you have dessert, you got to eat your vegetables, and I have a lot of spare parts over there that really need cleaned up and organized, and there's enough parts in here to build another turntable, so I don't want those to go to waste, so we're going to do just that. We're going to bring the turntable up to bare minimum turntable functionality without any automation, and we're just going to have a working turntable. So join me as we do that. So here's the mess we're starting with, a disheveled turntable with missing parts in a disassembled and totally non-working state. I really have my work cut out for me today, but I cast those feelings of doubt aside and start with the easiest part, which is taking things apart. I don't really care about having this automatic functionality, so I'm just going to remove everything until I'm left with the bare minimum amount of parts. I was originally trying to be careful with removing certain parts, like this limit switch, but eventually settled on breaking things to save me the hassle. The automatic functionality of this turntable is never going to work again anyway. I carry this same energy over to the switches, maybe minus breaking things. These are easy enough to remove, just a single nut needs removed, and we're cooking. The buttons are just as easily removed by unscrewing these slotted screws, and then we can lift out the assembly. A wire is broken off here, but that's no problem. I'll just fix that when I go to use this in the future. The speed sensor behind the pulley is pretty difficult to get to, but once I get my hands in the right place, it eventually comes out. Then I have to retrieve my nuts from under the turntable, which looks like this on the other side, by the way. This is what allowed that sensor to calculate the speed. Anyway, once I grab my nuts, the turntable slides back into the ball bearings with ease. The platter puts up a bit of a fight to get back in place, but after some careful alignment, it fits snugly into place. Then I have to remount the pulley that I accidentally pulled off when lifting the turntable out. This just needs pushed in and then tightened, using 2 screws that you can't see. Once that's done, it spins around just like a real turntable. Back to the movement hub, I disassemble some more stuff I know we won't need for this, such as this horizontal movement clutch assembly. I really think that after I have this completely disassembled, I might have enough of these screws that I won't need to buy any more for the next project. But if I do, at least it won't be as many. Alright, with the horizontal movement bits removed, I can get to pushing out the copper bushings. I've destroyed enough of these in the past that I think I have a technique down, but I probably should look into designing the hole they slot into a little bit better. I also need to remove these bushings from the horizontal clutch mechanism. This is probably how I should have designed the other holes. Next, I add a nut to the back so I can install this pin. The back of the tone arm pivot mechanism will bump into this, limiting its movement. Now it's time to drill the hole bigger so the movement hub's center tube fits. This is when I realized I never had the latest version of the hub installed on the turntable, which is a little bit scary, but we just stripped it of all of its automatic functionality, so I doubt there's anything that could go wrong. Once the hole's drilled out, everything seems to fit into place, just like I probably imagined it would 2 years ago. So after the dry fit, I installed all the nuts in their proper locations and started screwing the hub into place. This is a pretty finicky process since the nuts keep wanting to fall out, but once I start all 4 screws, it seems to go pretty well. Now that that's in place, we can thread the audio wires through the tube and tighten the tone arm using the 1 screw in the back. And yeah, that seems to be looking pretty good so far. To finish things off, I added the counterbalance weight to the back. In the 7-inch version of this turntable, the counterbalance weight was more than enough to offset the tone arm weight, but once I expanded to a full-size tone arm, it needed a little bit extra help, so I taped this bit and magnet onto the back. I dug around some more until I found the old tone arm lock, which tightens down with 2 screws. Like I said in the last episode, this thing looks pretty stupid, but it's rock solid. I had to dig around way too much to find that tone arm lock, so this is when I decided to go through all the boxes of parts. This one just has a few odds and ends, the vertical movement stepper, and this prototype from when I was trying to implement built-in anti-skate. I might set this aside, we could probably use this for ideas for a future implementation. I was pretty horrified to find the wide groove stylus just free-floating in this box. At least I had a cover on it, but man, goes to show the moving process was not kind to these parts. Once I took the good stuff out, I dedicated this box to all the 3D prints. The next box just has a stepper motor, a really tiny rubber O-ring, and a nice collection of nuts and screws. That one was easy. This next one just has some surface mount capacitors that I have no idea what their values are, the strobe transformer, and the LEDs the strobe used at one point. The next one is where things get a little more interesting. Here's the failed motor controller PCB, and the prototype that wasn't failed. I'll set this aside, I think we can use it for the turntable revival I'm attempting here. Once I flip through all these parts for the motor controller board, I find 2 breadboards that I've been looking for. I knew I had these somewhere, but I could not remember where they went. Now we all know. This next box has some more random stuff in it. I think this tube was going to be the tone arm. Not sure about this mess of wires though. Anyway, at least we have some more 3D prints to add to our collection. This box contained all of the PCB parts in the bags, as well as my original prototypes. Once those are out of the way, there's just a few sensors and switches that I used during the breadboard days of the project, and a few 3D prints of course. Now we've gone through all the boxes, I have to organize all these wires and other stuff. So I do that, and I'm having great fun with it as you can tell. After that, I think we have a pretty solid haul. I'll definitely be able to use a lot of these in future projects, and maybe even the next version of the turntable. Anyway, now that I've found more switches, I'm going to swap this 2-circuit one out with a switch that only has 1 circuit. It just needs to power the motor anyway, so the second circuit would just go to waste. Next, I install the spirit level I found using some tape, which makes it perpetually unlevel. But I didn't know where else to put it, so it lives here now. Then I fire up the bench power supply and give the prototype motor controller a test. And yeah, this thing is absolutely going to work perfectly for this project. It works so well that I wouldn't be disappointed if I had to resort to this method for motor speed control in the future. With that out of the way, I need to do something about the hookups on the back. I start by slicing the finest piece of warped oak I could find in the garbage, followed by drilling a precisely positioned hole for the DC power jack. I took the same level of precision over to the RCA jacks, which got holes of their own. Content with the holes I just made, I cleaned the piece of wood off with the most worn piece of sandpaper I could find. Then I hold everything up to the back of the turntable to get inspiration for how I want to mount it. Once I figure that out, I start hammering in the first nail, immediately splitting my already partially rotting wood. As a man who learns from his mistakes, I drilled pilot holes for the remaining nails, and then added a bunch of extra nails for good measure. Can never have too many nails in the project, right? The RCA jacks got screwed into the wood using these screws that came from my house's windows, and then the DC jack fits right in the hole and can be easily tightened down with a lock washer and a nut. Lastly, I cut some length off the piece since I made this way longer than it needs to be. And I think this piece turned out beautifully. It really matches the rest of the turntable. Now we can install it onto the turntable, which I do with some more window screws. With that installed, I found this really ugly switch, so I replaced the one I installed earlier with this one. At this point, I'm just throwing whatever parts I can at the turntable. This new switch is a little bigger than the previous one, so it barely fit through the hole, but I could screw it into place, and that seemed to work. The motor speed regulator just needs 2 holes drilled into it, careful not to hit any electrical components, and then once the holes are drilled, it can be installed with 2 screws. Now that everything's mounted in place, we can start wiring things up. I start with the motor connectors since I don't have to solder them, and then tie the motor's wire down with some twist ties. There we go, that should keep it out of the way. Next, I need to solder the ground lead of the DC jack to the ground wire of the voltage regulator, and then finish it off with some heat shrink tubing. The positive lead of the regulator gets soldered onto the switch, and then I remove this wire coming off the switch. I don't know what that was there for, but once it's gone, I can wire the center terminal of the switch to the positive terminal of the DC jack, and finish it off with some heat shrink tubing. Since this is solid core wire, I just push it into place and call it a day. The audio connections I soldered off camera, but those plug in together nicely. I knew something was missing, so I thought about it until realizing we're missing a grounding screw. So I drilled out a hole to slot the screw through and connected it to the negative terminal of the power supply. I don't solder it at all, I feel like a friction fit will be good enough. Like before, I just push this wire into place and my work here is done. To really bump up the quality of this build, I added the cheapest felt feet Dollar Tree had to offer. And you probably noticed this earlier, but this centerpiece is missing from the turntable. To solve that, I whipped up a model quickly that would fit here. Once I verified that it fits into place and that a record fits nicely around it, I superglued it down to the turntable. Hopefully this one can't be broken off like the last one did. Getting closer to the end, I thought it was time to dig for a 12-volt DC power supply, so I consulted my box of power supplies for a suitable candidate. It took me a while to find one, but I did succeed eventually. I really need to start building my own power supplies for these projects because I'm just going to run out of these eventually. When I tried to run everything for the first time, I heard some dragging underneath the turntable, and sure enough, these wires were, in fact, dragging. I solved this problem by adding a screw and then tying the wires to the screw. That'll keep them out of the way. Now that we're spinning freely, I can calibrate the speed. I shoot for 45 RPM using the strobe transformer and LEDs I found earlier, which is a little hard to see because I picked the worst LED color imaginable. But we get there, and then I can set the tone arm weight to about 2.2 grams. Finally, it's time to play a record, and then I immediately realize there's another problem. The rocker arm used for automatic movement is bumping into the wood block I installed earlier, so like any rational person would do, I just cut off the part that was causing problems. And don't worry, I remembered to plug the audio connections back in after I did this. After all that, we're finally playing a record. This is long overdue. And now that we're playing music, I wanted to see what sort of sine wave it would produce on the oscilloscope. The rumble from the turntable makes it wobble around a bit, and if you look really closely, you can visibly see a bit of wow and flutter, but it isn't near as bad as I expected it to be. In fact, when I was listening to music on this, I couldn't hear the fluctuations much at all. If a light 3D printed prototype turntable sounds like this and looks like this on the scope, then I think this thing is going to sound a whole lot better when I finish it off with a heavy turntable. I grabbed this acoustic research turntable to see what its sine wave looked like, and I was a little shocked to see it looks pretty similar to my homemade turntable. But when you put them side by side, you can see the acoustic research turntable's wave is a little more stable. Now, this oscilloscope wow and flutter test isn't very conclusive, but it at least tells us one turntable is better than the other. Anyway, enough looking at things and hearing me talk, let's listen to what it sounds like. So there you have it. We brought a functioning turntable into this world, and it sure does look. But I think this offers a good bit of closure for the past of this project, and I think this allows us to move forward to the next version. We'll always have this one to look back on, but in terms of what this could be in the future, I mean, it could be a pretty cool educational tool. This isn't really that expensive to assemble. I mean, when you think about it, it's just a motor, a voltage regulator, and some switches. Like, there's not a whole lot going on here. So if that's something you think you'd be interested in, you'd like to see a kit of this, let me know in the comments and maybe I'll make it happen. All right, that's all I got for now. So have a good day, and I'll see you in the next episode.